welcome to the Banujan Lecture Chemistry Ch101 Lecture 2. Here we have atoms and the periodic table, elements and the periodic table. So this is the important part where we're gonna be learning about all the periodic tables and the atoms and the elements of the science. Okay, and guys, please concentrate. If you guys don't like it, please go away right now. And this is really important, and I would like you guys to understand what it's all about. And please spare up with 15 minutes with us. And today you'll be learning all about the science in a short minutes. Here we go. An element is a pure substance that cannot be broken down into simple substances by a chemical reaction. Each element is identified by a one or two letter symbol. Okay, elements are arranged in the periodic table. The position of an element in the periodic table tells us much about its chemical properties. So what it basically says is that an element cannot be broken down. An element um, is identified as a one or two letter symbol. It cannot be more than that. And elements are in the periodic table, and the position of an element uh, in the periodic table, it tells us about the chemical properties like mass, all the stuff. Okay, atoms on the periodic table, here we go. These are the some of them atoms that you'll be finding in the periodic table. And I'm gonna just read over what is it there, because you guys need it. Remember all of those elements that is in the periodic table to keep your knowledge up and run. Here we have an element and symbol. Bromine is a Br, calcium Ca, carbon C, chlorine Cl, chromium Cr, cobalt Co, copper Cu, fluorine F, hydrogen H, iodine I, lead Pb, magnesium Mg, manganese Mn, molybdenum Mo, nitrogen N, oxygen O, phosphorus P, potassium K, sodium Na, sulfur S, zinc Zn. Okay, here we have all the atomics and the periodic table where it has a metal, metallite, non-metal, and right here you guys can actually see all the green parts here are metal, and basically a yellow, orange. Okay, basically orange are metallite, and all this highlight uh, blue are non-metals. Okay, the elements in the periodic tables are divided into three groups: metal, non-metal, metallites, like I was saying before. Metals are located on the left side of the periodic table, like I was saying, and the green highlighted. Usually exist as shiny solids, are good conductors of heat and electricity, are solids at room temperature except for mercury, which is Ag, which cannot be say at the room temperature, which is a liquid, right? And yeah, that's the toughest part of the mercury. Non-metals are located on the right side of the periodic table, usually do not have shiny appearance. They are usually poor conductors of heat and electricity, can be solids, liquid, gases at the room temperature. Solid, sulfur, carbon, liquid would be bromine, gas would be nitrogen, oxygen. Metallites are located on the solid in the lines that start at boron, which is B, and angles down towards an acetine, which is At. Metallites have properties intermediate between metals and nonmetals, and they are represented by only 7 elements, which is boron B, silicon Si, germanium Ge, arsenic As, antimony Sb, tellurium Te, acetine At. And here we have the same periodic table with the pictures of metal, non-metal, metallites. Okay, let's move on to item on the periodic table, which is the compounds. Compounds are pure substances formed by a chemical combining 2 or more elements together. A chemical formula consists of elements, symbols to show the identity of the elements forming a compound. All the compounds subscribe to show the ratios of atoms in the compound. So H2 is an hydrogen, O is the oxygen, and if it's individually or separately, they can be called as an element. When they combine, it become a compound. Okay, and there is a two hydrogen atoms and one oxygen atom. Okay, basically there's no S when we spell the atoms, when we pronounce the atoms. Okay, there should be one oxygen atom, and C3H8, which is carbon, hydrogen. There are three of the carbon atoms and eight of the hydrogen atoms. Compounds can be drawn in many different ways. This is an example. Here we go. H2O is a water, okay, and here we have an oxygen. Here we got the two of the hydrogen, okay, ball and stick representation, and here we have H2O drawn in a space filling representations. Okay, you guys might have studied this in high school, which you have to do a modeling of this compound for like infinity of exercise. Different elements are represented by different colors. Okay, and I remember you guys might have done this. Okay, let's see. Structure of the atom. All matter is composed of the same basic building blocks called atoms. Atoms are composed of three subatomic particles. Okay, subatomic particles are proton, neutron, electron. The protons has a positive one charge, neutron has zero, electron has negative one. Okay, and you guys don't need to know this. It's very tough. Okay, and structure of the atoms. Here we have a nucleus, location of protons and nitrogen, dense core of the atom, location of the most of the atom's mass, electron clouds. Okay, the location of the electrons comprises most of the atom's volume. Okay, here we have a neutron, proton. Neutron is always red. Proton is a positive sign, which is the in blue. And since we have a negative as a neutron, the color of it is red. And in here we have nucleus and electron cloud. This is how does it look like. Okay, and from the periodic table, let's look at what is the number behind top of the elements or bottom of the element. From the periodic table, we have three for the lithium at the top of it, top of the Li. That's called atomic number. Z is the number of the protons in the nucleus. Okay, so by figuring out uh, 3 right here, we'll be recognizing 3 as protons in the nucleus. And every atom of given element has the same atomic number. And every atom of a given element that has the same number of protons in the nucleus. Different elements have different atomic numbers. A neutral atom has not yet overall charge. So Z number of protons, number of electrons are equals. And here we have atomic number at and the element symbol of the lithium. Lithium basically have a 4 neutrons and 3 protons. Okay, whichever one is on the top, it's called proton. And then you got to uh, subtract the which level is the in which period table is where, and then you could find out the neutrons for that. Neutrons, not the neutrons. Okay. Sample problems: identify the elements that has a atomic number of 19. Okay, and give the number of protons and electrons in the neutral atom. Analysis: the atomic number is unique and two elements tell us the number of protons in the nucleus, the number of electrons could of cloud of a natural atom. And the solution according to the periodic table, the element potassium has an atomic number 19. A neutral potassium atom has 19 protons and 19 electrons. Identify the element that has an atomic number of 19 and give the number of protons and electrons in neutral atom. The atomic number is a unique to an element and tells the number of protons in the nucleus and the number of electrons of elect number of electrons in the electron cloud of a neutral atom. So the solution would be, according to the periodic table, the element potassium has an atomic number 19. Okay, a neutral potassium atom has 19 protons and 19 electrons. Here we have a mass number, atomic number. Okay, number of protons in nucleus. Mass number, number of protons plus number of neutrons, it becomes mass number. Okay, atomic number and element symbol, these are your own area, but top of them it will be in a quiz or test. And isotopes, atomic number and mass number. Isotopes are atoms of the same element that have a different number of neutrons. The number of protons, mass number A, the number of electrons. Mass number is 35 for the chlorine and atomic number is 17. So to find out the number of protons, it's whatever on the top or right here we are looking at 17. And the number of electrons are 17, number of nutrition. So every time I'm saying nutritions instead of neutrons. Basically guys, for neutrons you have to subtract protons, no actually from mass number to an electrons number to get the neutrons of the Cl, which means chlorine, basically called as chloride, but yeah. So we have all the isotope. Hydrogen has atomic number of 1 and the atomic actually mass number 1 and atomic number 1. And here we have a third one, atomic number is 2. Actually the mass number is 2 and the atomic number is 1. And here we have a mass number is 3 and atomic number is 1. Okay, the atomic weight is the weighting average of the masses of the naturally occurring isotopes of a particular element reported in atomic mass units, which is in AMU. From the periodic table, here we have an atomic number, element symbol, atomic weight, like I was saying before, and atomic weight is has a symbol which is AMU. Let's move on. I was just remembering what is there. Atomic weight. How to determine the atomic weight of an element? Here we have an example. What is the atomic weight of a chlorine, which is CaCl? Step 1. List each isotope, its mass and its atomic mass in units, and its abundance in nature. Isotope Cl35, mass is 34.97. Isotope isotopic abundance is 75.78%, which is 0.75. Oh, here we have a biology which is lying through like that. In the periodic table, basic features of the periodic table. A row on the periodic table is called a period, and the column in the periodic table is called as a group. Main group of elements consists of the two elements, two columns on the far left, and the size six columns on the far right of the periodic table. The groups are numbered 1A, 8A. Transition middle elements contained in the 10 short columns in the middle. These groups are numbered 1B, 8B. Inner transitions elements consist of the lanthanides and actinides. No group numbers are assigned. In group number 1A, alkali metal is there. All of these guys, you guys wouldn't have it on the test, but yeah, it's okay. So let's finish this lecture because you guys learn this there, and like I was saying, periodic table, remember all the mass and how do you find the proton, neutron, electrons, and atomic mass, atomic number, and that's about it. And thanks for learning, guys. Please let me know if you guys need any question. Please comment it. And this is Banujan Professor. Thanks a lot, and have a good day.